Now in this video, we're going to continue talking about matter, but we're going to talk about how we classify matter. And we're going to do this by following this decision tree or flow chart. So let's say you have some matter, you want to classify it. The first thing you need to ask is this matter pure or is it mixture? Pure matter or pure substance is made up of only one component, while mixture is made of more than one component. So let's say you're working with a pure substance. You have to ask yourself, is it an element or is it a compound? If you cannot break it into smaller parts, then you're working with an element. For example, helium. We cannot break helium down further. It's already an atom. While a compound, like water, can be broken down or decomposed into simpler substances. So here we have water, where oxygen is red, hydrogen is white, and we can break that down into oxygen and hydrogen molecules. Let's say you're working with a mixture. Well, you have two options if you have a mixture. Is it heterogeneous or homogeneous? So heterogeneous means different. That is, where you take your sample from matters, because every time you take a sample from a different place, it's going to have different amount of stuff in it. So for example, we have a wet sand here. Where I take my sample of sand matters because there will be different amounts of water and sand. While a homogeneous mixture, the example here is tea with sugar in it. This has been mixed completely, so no matter where I take my sample from, I'll have the same ratios of sugar to water. It is homogeneous mixture because it is the same throughout. So let's test your understanding. Classify the following by the type of mixture it is, the type of matter it is. Laundry detergent, carbon dioxide, iron, and dirt. So pause the video and do that now. All right, so the answers are detergent is homogeneous. If you take detergent, no matter where you take a sample of that detergent from, it will be the same. Carbon dioxide is made up of one carbon and two oxygens. These can be broken down, so it is a compound. It's not a mixture because it's just carbon and oxygen bound together. Iron is pure, it's just an element. While dirt, or dir as I have it, sorry for the typo, is heterogeneous. It's made up of a lot of stuff, and where you take dirt from really matters. Now in chemistry, a lot of the times what we do in labs is we want to separate mixtures. So we have different techniques to separate mixtures. And the first technique is called decanting. So let's say we want to get this liquid off from this sand. What we can do is we can get a stick. And then we pour the water slowly onto this stick and the water will come out, and the idea is to keep the sand inside this beaker. That's called decanting. The next type of technique is called distillation. And what we do in distillation is that we have a mixture and we heat that mixture to boil off the more volatile or lower boiling point or more easily vaporized liquid. So what is boiled easier rises first and goes into this condensing column. We have cold water going around this condensing column. So what happens is that the gas, the more volatile gas, cools back down into a liquid and it's collected into a different collection apparatus. And this is how we basically get gasoline. So shown here is how we distill oil. So we get crude oil from the ground and we heat it up. And then based on how heavy it is, we get different types of gas. So we have natural gas, gasoline, kerosene, lubricant oil, heavy oil, so on and so forth. And it's just by how it's heated up. Also, for those of you who like alcohol, you might look on your spirits that says double distilled, triple distilled. And so what that is just chemistry, where we're doing a distillation, where we have our alcohol, we heat it up, and then we collect the other liquid down here, which has a higher alcohol content. That's how you're getting your 70 and 80 proof vodkas. And the last technique that you'll probably use sometime during your chemistry education is called filtration, where we have a funnel here, and we have a filter paper, and we have a mixture of liquids and solids, and we pour that into the funnel. The solids are stopped by the paper, and the water goes through the filter paper. Those of you who like drip coffee, you do this every morning. You do chemistry every morning through filtration. Your coffee grounds are stuck in the filter and the water goes right through. And so that's the end of our video, and thank you for stopping by. Whoa.